In this section, we're going to be working with integers. Integers are very important because you see them all through mathematics. So let's start off by drawing a picture. Drawing a picture helps us get a better idea, a better look of what's really going on. And when we're dealing with integers, we're going to be dealing with what's called a number line. A number line is nothing fancy, it's simply a line with a bunch of numbers on it, a bunch of integers. We're going to start with having our 0 in the middle. Now this is really important because on the left side of 0 are going to be all of our negative numbers. On the right side of 0 are going to be all of our positive numbers. So let's go ahead and list out a few of these. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And this keeps going on into positive infinity. Now on the left side, we're going to have all of our negative numbers, which is going to be very similar to the positive numbers, only they're going to have a negative sign. So let's get started. We're going to have a -1, -2, -3, -4, -5, -6, -7, -8, -9, and a -10. And this keeps going on into negative infinity. A number line is very useful when dealing with integers, and especially when we're ordering integers. So let's do a couple of examples. We're going to order the following numbers from least to greatest. From least to greatest. Here we have 1, 5, 0, -2, -4, 3, and 2. Now the first thing we want to look at when we're ordering from numbers from least to greatest is we're going to be working from left to right on the number line, so we're going to look for the negative numbers. The negative numbers are obviously less value than our positive numbers. So we have two of them here. We have a -2 and a -4. Now we need to be careful when dealing with negative numbers because the greater the number is, the less value it actually has. Or the more negative, you can think of it that way. So the least value we're going to have is -4. We can mark these off as we go. The next is -2. Now after we get done with our negative numbers, going from least to greatest, we want to look for a 0. 0 is a special number because it's neither positive nor negative. It actually separates the two groups. And now we can move on to our positive numbers. And these are more straightforward, and going from least to greatest, we have 1, we have 2, 3, and 5. Now we can check this by looking at our number line. Since we're going from least to greatest, we're going from left to right on the number line, and we can see that -4 is here, then -2, then 0, then 1, and so on and so forth. And we can see that this is indeed ordered correctly from least to greatest. Let's do another example. We're going to order from least to greatest the following numbers. We have an 8, a -8, a 4, -4, -2, -5, and 6. We want to order these from least to greatest. So going left to right on the number line, we're going to start with our negative numbers. The greatest number on the negative numbers is a -8, so we're going to start there. That has the least value, or the most negative. The next, we have a -5, then we have a -4, and -2. We don't have a 0 here, so we can jump straight to our positive numbers, and going from least to greatest, we have 4, 6, and 8. And again, we can check this on our number line because ordering from least to greatest, we're going left to right on the number line, and we can see that this is indeed correct. -8 is here, -5, -4. Let's do one more. This example, we're going to order the following numbers from greatest to least. We have a -1, a -4, 0, -2, 2, -3, and 3. So we're going from greatest to least. So this time we're going to start going from right to left. Our positive numbers are of greater value than our negative numbers. So let's find our positive numbers first. Well, we have 2 and we have 3. 3 is obviously greater value than 2, so we're going to start with 3 and then 2. We have a 0 right here, so we put that in the middle. 0 separates our positive numbers from our negative numbers. And then when we look at our negative numbers, we're looking for the one with the greatest value, or the least negative. And that's going to be a -1, -2, -3, and -4. And again, we can check this just like we did in the other ones on our number line, but going from greatest to least, we're going from right to left. We can see that this is indeed ordered correctly. Now, in the last two examples, we saw something really interesting. Up here, we had a +8 and we had a -8. Here, we had a +3 and a -3. We had a +2 and a -2. These have a special name, and these are called opposites. Opposites. All an opposite is two numbers, well, actually two of the same numbers, one with a positive sign and one with a negative sign. So we have a +2 and a -2 here. These are called opposites of each other. And what we want to discuss now is how we find the opposite of a number. So let's find the opposite of -1. Well, our rule says that we simply multiply the number that we want to find the opposite of by -1. -1 times -1 is a +1. +1 is called the opposite of -1, and -1 is called the opposite of +1. Let's do another example. And this seems very intuitive and straightforward, but let's find the opposite of the expression x + 2. Now, some of you might be thinking, well, the opposite of x + 2 is x - 2, and that would be wrong. We want to multiply, our rule says multiply the entire expression by -1. And this turns out that the opposite of x + 2 is a minus x + 2. Later on, we'll be going over something called the distributive property, which will actually help us more clearly see that the opposite of x + 2 is indeed minus x + 2 and not x - 2. Not x - 2. And again, that's a distributive property, and we'll be going over it in a later section. But for now, let's do another example. Let's find the opposite of a -2/5. Well, we deal with this with rational numbers the same way we deal with integers. We multiply it by a -1. The -1 cancels with a negative sign, and all we're left with is a +2/5. 2/5 is the opposite of -2/5. Next, let's find the opposite of x squared. We do it the same way. We multiply by -1. Now, we don't multiply the exponent, we multiply the entire expression by -1. The opposite of x squared is a minus x squared. Let's do a decimal. Let's find the opposite of 4.1. Well, we know how to do this because we found the opposite of an integer. An integer is simply a decimal with a 0.0. So the opposite of 4.1 we find by multiplying by -1, and we get a -4.1. Let's do one more. Let's find the opposite of -2y - 1. What we're going to do is we're going to multiply the entire expression by a -1. The -1 cancels with the negative sign, and we're going to have a positive 2y - 1. And hopefully this is easier to see that the opposite of a -2y - 1 is not 2y + 1, but it's a positive 2y - 1. We need to go over these a few times and make sure we get this. Now, what did we learn? We learned a few properties about integers. We learned the difference between negative integers and positive integers. We learned how to order from least to greatest and from greatest to least these negative and positive integers. And we also learned about opposites. We learned about what exactly an opposite is, how to deal with them, and actually how to find the opposite of a number. These two topics are very important because we'll be seeing them all through algebra. I'll see you soon.